So this is a lovely circle theorems question that we need to look at. So first of all, we're finding the angle of ABD. So going from A all the way to B to D. And what this is an example of the alternate segment theorem. I borrowed these from Corbett Maths, which is great. And we see here we've got a tangent along the bottom, and then this triangle inside, and on the tangent this angle matches up with this angle inside the triangle, and this angle matches up with the other one. And we can see we've got this situation here. So I've got the tangent here at A, and then I've got the yellow angle, which I know here, and that's going to match up with the, see the blue triangle that I've highlighted there. So those angles will be the same. And also those two dark blue angles will also be the same. So this is one of the trickier ones to spot, I think, alternate segment theorem. Anyway, either way, that yellow or green angle, ABD, that I've highlighted there, is the same as the other one. So that's 42 degrees. So next is angle ACB that we have to find here, part 2. And I've highlighted it there. This is a more familiar circle theorem, I think. A bit more clearly, I think, if I highlight the whole shape there that we're looking at. And it's this one. So the angle at the circumference, which is here, is half the angle at the centre, which is here. So in this case, the angle at the centre is 142. So angle ACB that we need is going to be half of 142, 71 degrees. Next up is part 3, which is angle ADB, which I've highlighted there in red. And that is a cyclic quadrilateral, which I've highlighted here. So the opposite angles have to add up to 180 degrees. In the quadrilateral that I've highlighted there in blue, that every edge of that quadrilateral has to lie on the circle itself, and the opposite angles are obviously these two. Subtract from 180, we get 109 degrees. But we're finding angle BAD. Nice one, because you see, I've nearly highlighted it all. That angle there is in green, BAD, and it's just angles in a triangle. So we know two of the angles, 42 and 109, so we just subtract from 180. That we get 29 degrees. The next one is angle APB, which I've highlighted there in green, and for this one we can use this circle theorem. So the tangents to a circle from the same point will be an equal length. So this creates an isosceles triangle, which I'll show you now. Those two lengths will be equal, and as we know this angle, because we can add those two which we've already found together, they're trying to sort of lead you on there. So that would be 71 degrees. That means the other angle will also be 71 degrees here. And as it's an isosceles triangle, we just add those together and subtract from 180. We do that, 180 minus 71 times 2 should give us 38, which is the missing angle. This is quite a multi-step problem. So I've sketched it out as best I could with what we know. The two radii there, they are in green, they're both 11. And what we're going to do, first of all, we're going to find that missing length. And then we're going, so we've got one length of the triangle, and then in order to use the formula here, half BC sine A, we need to find another length. So either BD or AD, because then we'll have the trapped angle that we need to work to apply that formula. Start then with finding length AB. I created a right angle triangle here in the middle, so I split up the two green radii, and put a right angle triangle in the middle. So I can transfer this across to here. That's triangle AOX. I've labelled the X to set up a right angle trig situation. So if I find length XA, big XA here, and then double it, it will give me the yellow line I need. So this is one way to do it. You don't have to use right angle trig, but if you can use right angle trig, you know, it's generally easier. So I have applied right angle trig. So looking at angle 71, that is the opposite, and that is the hypotenuse. So using opposite and hypotenuse, so we're using sine. So sine 71 is x over 11. I've rearranged it, try and find x, so which would be this, but then recalling that that is only half the length. So it would be from there to the centre, but it's double that. So it's going to be approximately equal to this length for AB. So this is the triangle we're now looking at with all the information we've got. So we need to work out one more length before we can apply the formula for finding the area of a triangle. I use the sine rule. I'm going to choose to work out this length here, just pretty arbitrary. I could have chosen the other side, but that I'm just going to show us that it makes a lovely cross here. So there we go. So it's made a lovely cross with opposite angles and sides. So we know we're using the sine rule. Out the sine rule, and I'm just using the lengths and the angles opposite it with using A and D, the ones that we're looking at in this question. I then substituted in to the sine rule. So I've substituted in angle A here and side D here, opposite angle D here. I then rearranged it to get the answer for side A, which I've written there, highlighted or underlined in yellow. I'm going to hopefully show how simple it is to apply the formula for the area of a triangle. What you need is a trapped angle. So I know side D, I worked it out earlier. I know angle B, and I know side A, which is on the other side. So that angle is trapped by sides that we know either side. You just really need to think that it's a trapped angle. So I mean, if you look at the formula there, it's half BC sine C. So C is here. The angle is there, and then the other side is on the opposite is on the other side of the angle. So it's a trapped angle. You just need either side plus the angle in the middle, or both sides and the angle in the middle. So you can just list it out really. So side D, which is one of the sides, is, oh sorry, you need to times it by half of course. So it's a half times side D, which is 20.8014, times by the other side, which is 10.6658, and all that times sine of the angle in between them, which is between A and D is 42. So it's this trapped angle here. There it is, just listed out. And to three significant figures, that should be 74.2.